What if you could make your website look like one thing for security scanners and bots and other automated systems, and something totally different when humans look at it? Today, we're looking at one of the most misunderstood components of the phishing ecosystem, traffic cloaking. It's a technique attackers adopted from the world of ad fraud. And if you want to understand why phishing infrastructure can be hard to detect, this concept is foundational.
Behind the surface, follow the chain from initial access to lasting pain.
Welcome to Behind the Surface. Here, we deep dive into the real tactics and techniques driving today's cyber attacks. Not in theory, but in practice. Every episode breaks down what threat actors are currently doing, translating their underground methods into clear, analyst-friendly insights. Whether you're a defender, a researcher, or just curious about how modern attacks actually work, this channel is built to give you the visibility and vocabulary you might not find in glossy reports. No hype, no fear-mongering, just grounded technical analysis of the tools, tricks, and ecosystems powering cybercrime. We will go over what traffic cloaking is, how it works, the history of traffic cloaking, how it's used in phishing campaigns, and then we will observe traffic cloaking on a live attack in the wild. Traffic cloaking comes from the world of traffic arbitrage. That is, buying internet visitors at a low price and selling them at a higher price. Now let's suppose you have a friend who runs a cryptocurrency casino. They make a lot of profit off each customer, so they offer you a significant commission on each customer you send to their site. How can you get visitors to send to the crypto casino? You could buy cheap Facebook ads or Google ads. Some of you might say these aren't cheap compared to some other options. And you send those visitors to the crypto casino. You make a fat, easy profit off of that traffic, right? One problem. All of the major advertising networks have a lot of strict policies. They don't allow crypto casinos. They'll quickly catch you and shut down your account. In order to make money, the traffic arbitrage folks had to figure out how they were being caught so quickly. And the answer is that the advertising networks have armies of bots to search for policy violations. So, arbitrageurs came up with cloaking, sending these bots to what they call a safe page or white page that matches policy, maybe it's along the same lines, the same theme. This could be a technical analysis of cryptocurrency, for example, while sending the real human customers to the money page, the actual crypto casino. In this way, the ad scanners would not pick up that policy violation. Back to phishing. Phishing operators were getting their domains flagged by security vendors faster and faster by those vendors' armies of bots. They saw what the arbitrage teams had done and adopted that approach into their phishing kits. Now, when following a phishing link, security vendors' scanners would see, for example, the technical analysis of cryptocurrency, while real humans would see the money page. In the case of phishing, the page that steals credentials or credit card numbers, or usually browser cookies. Of course, the vendors try to bypass the cloaking by making their bots look more human, and the phishing operators try to prevent the bypass by more accurately identifying the bots. It has been a cat and mouse game ever since, in which different vendors and operators work at different levels of sophistication. The first cloaking simply looked at the user agent string. That's a header sent by the software that retrieves the page from a web server. A Python library, for example, would use a different user agent string by default than Chrome browser. So then, you send requests from the Python library to the safe page, and you serve the money page to requests that come from the Chrome browser. But that was trivial for scanners to bypass. They simply sent a different user agent string so they would look like a human using a web browser. Next came lists of known bot IPs. Cloaking providers would track IP ranges used by scanners and send them to the safe page. This works against low sophistication scanners. However, sophisticated ad networks and security vendors have access to a large and varied selection of IP addresses from different types of networks. This could be not just data centers, but mobile device networks, residential IPs. Higher sophistication cloakers use the device fingerprint. The fingerprint refers to the combination of a lot of data that the browser will send to the web server to get the optimum experience. This data includes not just the user agent, but things like the screen size, the graphic capabilities, the audio capabilities, what fonts are supported by the browser. There are dozens of these factors that the server can request, and the browser will provide this information. And combined, they often can produce a unique fingerprint that can identify a browser uniquely on the internet. You can go to a website like this, Am I Unique, and see your fingerprint and see if you are unique. If you are, that makes it easier to track you. But the bots had a particular fingerprint that the cloakers could pick up on. And then the bots picked up on this. So, of course, what they did next was randomize their fingerprint. That didn't last long either, because a human configuration, a real computer configuration, is not random. People have a certain range of screen sizes. There are common fonts, common hardware. So then random became a red flag. Next came behavioral analytics. How does the mouse move? Does the mouse move at all? Does it move in a straight line to a button? Does it sort of stay for a second, move around a bit more randomly, like a human might do? And then text, keystrokes. If text is entered on this page, what is the pace and variation in keystrokes? If you look down at your keyboard, you put your hands in the QWERTY keyboard standard position here, and you hit the P, you might find that it just takes you a little bit longer to hit the P than the J. And factors like that can be analyzed statistically. Maybe a bot does not take longer to hit the P than the J. Maybe the bot puts some random variation in, but it's random, and it doesn't correspond to the same variation you see in a human. And you can use computing power to analyze that, use machine learning, see one is a human, one is a bot. Analyzing all of this data effectively, though, takes a very large sample size and sufficient computing power to conduct the machine learning. This is not only something that scales well, but something that can really only be done at scale. And this large-scale machine learning is exactly what tools like Adspect do. Adspect is often considered the gold standard of traffic cloaking, or just a necessary requirement. Although if you look at the features of the product on their page here, you'll see that they boast about blocking Google Safe Browsing, Virus Total, other security tools. You might wonder, why would a tool intended to prevent ad fraud want to block Google Safe Browsing and such? Well, their response is that they have no insight into what their customers use their tool for, and they have no policy against any type of content. All they do is serve an API. This API accepts a fingerprint sent by a customer's web server, and it returns a categorization. Is this a human? Is this a bot? That the categorization is used by the customer's web server to decide where to send that visitor, to the money page, to the safe page. And this is an expensive API. To get the full features that are actually needed for this proper cloaking of ads and potentially phishing sites, other sites, it's $1,000 a month. Operators say that it's worth every penny, though. Not everyone's happy with it. It is notoriously conservative. This means that it sends a lot of traffic to the safe page instead of the money page. And a lot of customers are not happy with that because they get less traffic on that money page, and they perceive that as less revenue. Well, it certainly is less revenue in the short term, but think about it long term. If you're running something high risk, something that's going to get your account shut down, something that's going to get your domain flagged by security vendors, you're running something high risk, you understand the trade-off offered by conservative cloaking. You know that getting your infrastructure shut down is going to hurt your traffic a whole lot more then a conservative cloaking approach will hurt it. This particular critical reviewer says that Adspect is way too conservative, and apparently Adspect has never worked with traffic arbitrage themselves. Well, perhaps there was a different use case in mind when they developed the default settings. One more thing I want to bring up before we go on to the live attack is that these factors we've been discussing, IP address, the type of device, the type of operating system, user agent string, those can be used not just for cloaking, but for changing how the attack works. For example, some attacks only target certain countries, so this will avoid targeting a country that they don't want to target. They'll send visitors from that country to the safe page. Or if the attack is targeting a specific type of device, certain attacks don't work on mobile devices, don't work on Mac OS maybe. It'll use that and give you a different attack or a safe page or some sort of other ruse if you visit from that type of device versus the target device.
With detective lock, the signal's clear. Breaking it down logically here.
Today I found a phishing site that I assessed was a deployment of what Sequoia has called the Mamba 2FA phishing kit. Now that is a man-in-the-middle proxy phishing kit that is sold as a phishing as a service platform. And if you want more information on this particular kit, you can go to Sequoia's blog. They do great analysis, but we'll focus on the traffic cloaking for now and not so much on this kit or phishing as a service in general. So let's pull up the site. You can see here we get a prompt for Microsoft credentials. That's the most common target for adversary in the middle or man in the middle phishing kits. And this means this is the money page. We got to the page that the attackers want human visitors to see. That makes sense. We're human visitors. Well, myself, maybe not Detective Locke.
What am I, if not human? Do I have a soul, or am I just a mechanism of mystery?
That's what we expect to see here. And we can try out the page, put in some nonsense credentials. It'll check those credentials against Microsoft, and it'll return an error because that account does not exist. If we want to see traffic cloaking in action, we'll need to take a look at the page from the perspective of a security scanner. For this, we can use urlscan.io, the community edition. URL scan is pretty powerful. Even the community edition has a lot of features. If you look here, though, one of the things it can do for you is detect phishing sites. Plug the URL into the URL bar of urlscan.io to have it load the page and do some preliminary analysis. What do you expect we might see here? We're going to see the money page. Well, the scanner isn't reporting anything malicious in the results here, and in the screenshot and title, it's actually indicating a Google 404 error page. That's interesting. Well, the Google 404 error page is the typical safe page for the Mamba 2FA phishing kit. So it's not surprising. We're seeing here that traffic cloaking was successful against urlscan.io. It did not see the money page. It didn't pick up any malicious indicators. However, the fact that the Mamba 2FA phishing kit uses the Google 404 error page consistently for its safe page, that's an indicator that we can use to our advantage. If we see a link that's been reported to us by a customer or a client, or we find in the wild, and our tools are showing it leads to a Google 404 error page, well, we didn't go to a Google domain. What's going on here? To a human perspective, maybe that doesn't make sense. Well, that's an indicator we can use to say, hey, maybe this link is malicious. Maybe it's using traffic cloaking, and it's maybe a Mamba 2FA phishing kit page. Of course, to say that with high confidence, we'd have to find other indicators, look at the source code of the page, look at the behavior of the page, but we can actually use that safe page to our advantage from a human perspective. Well, thank you for joining Detective Locke and myself on the first episode of Behind the Surface. I hope you enjoyed it and maybe you learned something about how phishing operators are evading security vendors. If you've got any questions or insight, don't hesitate to leave a comment. Till next time.
Behind the surface, follow the chain from initial access to lasting pain. With detective lock, the signal's clear. Breaking it down logically here. Process injection, deep in scripts. Toolbox uncover all play